Use the substitution method or the elimination method to solve the system. The system of equations that we have is y equals 4/7 x minus 5, and the equation negative 2x plus 21y equals negative 105. Now we're asked to solve this system with either the substitution method or the elimination method. And when you have the substitution method, your first step is to rewrite one of the equations by solving for a variable, either x equals or y equals. So I'm noticing that we already have one of our equations in that format with the y equals. The other method, the elimination method, you want to have all of your like terms lined up. So the system needs to look something like this. It doesn't have to look exactly like this, but most of the time this is what it would look like. And what you'll see here, I've got a mistake there, let me correct it. I put a plus here and that should be an equals. So what you should see is that your equation is lined up along the equal sign, and then all of your like terms are kind of stacked on top of each other, so that when you add the equations together for the elimination method, you're already lined up to combine the like terms together. And you can see that we do have the equal sign lined up here. However, our like terms, x, are on opposite sides. We do have the y's on the same side. So this system is not really set up right now for the elimination method. Now that doesn't mean that you can't use the elimination method, but there's some work to put in before you can start applying that method. So because of the way this system has been set up, I'm going to lean towards doing the substitution method because it's already ready for me to start that process. So I'm going to use that substitution method. I've already got y equals. So my next step is to take the expression on the other side of the equation, 4/7 x minus 5, and substitute that into y in the other equation. And that's going to give negative 12x plus 21 times 4/7 x minus 5 equals negative 105. I'm going to use the distributive property and distribute that 21 to both terms inside the parenthesis. That's going to give me negative 12x plus, well, when I multiply the 21, 7 goes into 21 3 times, and 3 times 4 is 12. So I have a 12x. And then 21 times 5 would be 105. That's a minus 105. So I've got an equation with only one variable in it. I'll start combining those variables together. Negative 12x plus 12x comes out to be 0. And now all of the variables have canceled out. And I end up with this statement, negative 105 equals negative 105. Now that statement is a true statement. So when you have a system where all of the variables end up canceling out, you know that you have a special case of the system. And because we ended up with a true statement, we know that this is the special case where these two lines, this equation and this equation, happen to be the same line. So they are the same line that are right on top of each other. I can show that if I take the second equation, negative 12x plus 21y equals negative 105. If I take that second equation and I solve for y, I'm going to add 12x on both sides. That's 21y equals 12x minus 105. And then I divide by 21 on both sides. That's going to give y equals, I would reduce that 12 over 21. Let's see, 3 goes into 12 4 times, 3 goes into 21 7 times. And if I divide negative 105 by 21, I'm going to get a negative 5. So you can see that that second equation, when we rewrote it in slope-intercept form, is actually the same as the first equation. So this is a system where we have two lines that are sitting right on top of each other. The solution to the system will be all of the ordered pairs that fall on top of that line. So it's not just one ordered pair that's the solution, it's all of the ordered pairs that are on that line. We would not include any ordered pairs that are not on the line, so we only want to include the ones on the line. So to say what the solution set is, we could write that in set builder notation. Set builder notation is where we write curly braces. We are going to state here what the solution looks like, or what the items in the set look like. The items in this set are all ordered pairs, and these ordered pairs need to specifically be on the line y equals 4/7 x minus 5. So the way that we read this is that we have a set of ordered pairs, and those ordered pairs must be on this line. Another way to write it is to write out an ordered pair, an x and a y, but we don't want to have two variables. So instead of writing the y, I know the y has to be 4/7 x minus 5. So ordered pairs of this form, x comma 4/7 x minus 5, will be ordered pairs that satisfy this system of equations. Thank you for checking out my videos. Have a great day.